Okay, so um, somehow I don't believe him. Huh? Okay, so there is a remainder. So this is a part that is always confused students. Is this particular part here? Sorry, let me go to QuickTime. This is a part that is gonna confuse most of the student. Is what is that mean? But it's not difficult to do. It's not difficult to do. So so what we're gonna do is we're gonna give you a function. We're gonna say, for example, yesterday's function we have cosine of 0.8. Uh, Today we're gonna do f of x is equal to natural log of x, and we say we want to approximate natural log of 1.1, and um, and we wanted to get to the fourth degrees using Taylor polynomial polynomial uh polynomial, not Taylor series, to the fourth degree. Okay, so I want you to figure out what a fourth degree. So that means how many derivative I have to take. Fourth, but fourth is only in the polynomial. You want to take to the fifth, because the fifth you can find the error. How precise are they in terms of approximation of 1.1? So I want you to go ahead and do this. I want you to go ahead to take fifth derivative and write down the fourth degree Taylor polynomial, like fourth degree Taylor polynomial. Okay, so I'm gonna give you a head start for like 1 minute, but I'm gonna work it all out. You want to go to fourth degrees for the polynomial. You want to go to fifth degrees for the error. Does that make sense? So n plus 1 is the fifth degree. So you want to go to the fifth degree to find out what the error is. Now, this is a very common question, but it's just worded very difficult to word it. And so a lot of people mess up this part. I think including, I was watching Red Pen and Blue Pen. He said that was the only question that he really like not sure, because when he was in high school, the teacher didn't really explain the he actually make a video about like that's the only question that he wasn't sure, but he write down this formula, and he said at the time I didn't know how to use this formula. Yeah, so but he said looking back, this is actually not a hard question. They just have to decide what is it. So I want you to take a fifth degrees and write down the first four term of things. Center? Whoa, good question. What should I put my center at? What's a good place to put my center? Why 1? Because we know natural log of 1 is what? 0. So center should be at x equal to 1. Good question. Whoever asked that, very good. Because
so do we want like x to the negative fourth, right? We don't want the fourth term.
We want it to the fourth degrees. Okay. So you're
so like for example,
so it will be probably
we would want 2 terms versus
what?
So if it was like cosine, we would want 2 terms. Right?
No, you just stop at the degrees. Yeah. So they will, so stop at a degree. So it's a fourth degrees, then you stop at fourth degree. That means you need to take fourth derivative to get to fourth degree, because that's what x minus c to the fourth comes in, right? Sometimes they say non-zero term, like the second of like a second of non-zero, a third of non-zero term is gonna be like for cosine, it'll be like, you know, f of 0 and maybe the second degree and the fourth degree. So that would be third non-zero term, because you have, longest they are center at 0. But if you are center at pi over 6, then you have all the term. Just like what you question was yesterday, was the center is at pi over 6. Therefore, you base on pi over 6 to build a function. So you base on sine of pi over 6 here to start it. So right here, the center, we want to be at 1. So C equal to 1. All right, so your minutes up. So f of x equal to natural log of x. F prime of x is equal to 1 over x. Is that okay? F double prime of x is, this one's x to the negative 1, so it'll be negative 1 x to the negative 2. X, oh sorry, to 2. X triple prime of x is going to be, this one is equal to x to the negative 2 negative. So that's going to be 2 over x cubed. F to the 4th derivative is going to be negative 6x to the 4th. Is that okay? And f to the 5th x. Now this is to build your Taylor polynomial stop at 4 degrees. The 5th degree is used to find error. And we're going to go to the error part. It's going to be 24x to the 5. It's okay? Any questions here? Now, also, we're going to plug in the C. So f prime of, sorry, f of a 0 is what? I mean, sorry, f of 1 is equal to what? 0, right? F prime of 1 is equal to what? 1. F prime, f double prime of 1 is equal to what? Negative 1. F triple prime of 1 is going to be 2. And f to the 4th prime of 1 is equal to negative 6. And f to the 5th of 1 is equal to 24. So we know this. So what we're going to do is we're going to write down a polynomial. The way you denote it on the AP exam, you're going to denote as p to the 4th. That means polynomial to the 4th degrees.
So it's not the sum of 4?
What do you mean?
It's not S4. It's P4.
No, it's P4. It's because we are deal with polynomial rather than series. So series is going to infinite, but if I have a polynomial, we stop at 4 degrees. So we're going to write out a first term, which is f of 1 plus f prime of 1 of x minus 1 to the over 1 factorial. I don't need to write that down. F double prime of 1 of x minus 1 to the 2nd over 2 factorial plus f to the triple prime of 1 of x minus 1 to the 3rd over 3 factorial. And we stop here. So f of 4 of 1 times x minus 1 to the 4th over 4 factorial. So we stop right here. Once we stop, if we want to evaluate like 1.1, but we can simplify, of course. Let's go try to simplify it. So p of 4, if I simplify f of 1, is going to be what? 0 plus this is going to be 1. So it'll be 1 times x minus 1. Is that okay? Yeah. Minus x minus 2 to the 2 over 2 factorial. This is a negative, right? Yeah, this is, I just replaced as a negative. Oh, my x minus 1. Oh, sorry. Dyslexic. 2. Is that okay? Now plus f triple prime is 2 x minus 1 to the 3rd over 3 factorial plus what? F of 4 is negative 6 times x minus 1. Well, this is a minus 6 to the 4th over 4 factorial. This is minus. Now, can I simplify more? Slightly. X minus 1 to the first. Well, this one's 1, so that's literally just x minus 1 squared over 2 rather than 2 factorial. And this is 3, so that means this is 3 times 2 times 1. So the 2 and 1, this 2 cancel out, so it's going to be plus 3 over x minus 1 to the third. Does that make sense? Minus 6 is equal to 3 times 2 times 1. And the 4 factorial is equal to 4 times 3 factorial. So this cancel out, left with the 4 of x minus 1 to the 4th. So this is the 4th degree polynomial. Now, p to the 4, if I want to plug in 1.1, I just plug in 1.1 all of them. Now, you can use calculator to figure that out, and I have no idea what that is. So I know it's 0.1 minus 0.1 over 2 plus 0.13 minus 0.1 to the 4th over 4, and that is the approximation. Now, back then, you gotta understand when Taylor, this is 400 years ago, and 1600 or 1700, I don't know how long ago is that, they didn't have a calculator to figure out what's natural log of 1.1. But they can figure out by using this to figure out what 1.1, natural log of 1.1 is. By the way, a long time ago, they used something called, do you guys remember there's something called slide rule? Slide rule is a ruler that they can measure like natural log of value, but it's hard to measure, hard to find out like, but that's only built, and the slide rule is built in like 1900s, maybe 1930 or 1950s, and where you have the older slide rule, like you can calculate square root 2 or square root 3 or square root 4. You can use a special ruler and you just move along with it. Nobody knows how to use that this day, but if you're an engineer back in 1960, using nice slide rules, because calculator is still like a TI 11 or TI 12. It's just big as this room, so it's going to take a long time to do. So that's approximation of this. But how accurate is this? How do we decide the accuracy? Is the accuracy plus minus 0.1 or plus minus 0.01? We got to go find out what is the accuracy. So that's why we need a remainder to figure it out. That's why we need a remainder, right? So remember, remainder of 4 of x is equal to f to the 5th of z times x minus 1 to the 5th and the 5 factorial. Now the z here is kind of hard, so I will want you to think about that. You want to have a maximum. 5, yeah, it's m plus 1, right? So 4 plus 1. So it's f. Not yet. So we want to figure out what the z is. Now let's figure out what's f5. From what we had before, what's the 5th? Okay, what's the 5th? Well, 5th of x is equal to 24 over x to the 5th, right? But we said we wanted the z, so 5th of z, that's equal to 24 over z to the 5th. Now z, I can choose what is going to give me the maximum. So for example, there was 2 values I should consider. One is at center, one is at the edge of approximation. Do I want to choose, what is the center here? What's the edge of approximation? What's the one we're trying to approximate? 1.1. So is bigger to plug in 1 or 1.1?
One.
1, because you only want to divide a bigger number. If you divide it by a bigger number, it becomes smaller. So you want to divide it by a small number. When the z is on the bottom, then you want to make sure that you want to use a value that's give you a small value. So therefore, I'm going to use 1. So f5
So those are the
of
only two
1
numbers that you can
is equal to 24. Because you want a z to choose between 1.1 or 1. But you want to pick a value that is, hey, I want to pick a value that's more reasonable for me. I want a maximum because I want my maximum error. I don't want my minimum error. I want my maximum error. So I wanted a z to be a possible to give me output that's a maximum. But between 1 and 1.1, 1 is a better choice. So 1 is better choice, right? Better choice. Then 1 is better than 1.1 because 1.1 is going to give me a smaller value. That's giving me a smaller error. We want a maximum error.
So you can only do those two different numbers.
Yes, because we have a center, we have the edge of the center, right? That's the interval convergence. That's the radius of convergence. So that's going to be from 0.1 or 1 to the 1.1. So therefore it's 24. So then therefore we have R4 is equal to 24 times 1.1 minus 1 to the 5th over 5 factorial. And if you really want to simplify this, 24 is equal to 4 times 3 times 2. It's a 4 factorial, right? Over 5 factorial times 1.1 to the 5th. So that becomes 5 times 1.1 to the 5th. And that end up to be 0.0000002. How accurate to the fourth degree? They are 0.000002 accuracy. Without a calculator, you can calculate this, and with the highest, the smallest error. So if you want to find an interval, right? If you ever want to find an interval, is this result, I don't know what this result is, plus minus 0.000002. The accuracy, usually we go with the absolute value of it because we have a plus minus. We have plus minus. So when the question is asking how accurate it is or what is the interval, you can have plus the error and minus the error. That becomes the interval, just like what you did on your last test. The last time we did AST remainder. AST remainder will be asked throughout the AP exam. Taylor remainder is asked more often. It's about, I will say, 80% of the time they ask Taylor remainder because you have a maximum involvement. 20% of the time they ask AST remainder because that the remainder is your next term. It's not a very complex idea. It's something that we have done. Okay, somebody raise their hand. Elise?
V is basically either the center that you chose or the number that you're trying to approximate the value for.
But you want to pick a value, give me the maximum output. Because we want to know the maximum error rather than knowing minimum error. So if I divide it by 1.1, so it'll be that value divided by 1.9. It's going to be slightly bigger rather than divided by 1. So you want to divide a value that give me the maximum output rather than minimum output. Because we want to know the maximum error it can possibly be.
So you said you're dividing by 1.
Yes.
And then so that wait, 1 more.
Because if you have a number divided by 1, so 2 divided by 1 is bigger, or 2 divided by 1.1 is bigger. Right? So you want to choose a number that where it's give you the bigger value.
Or it's like where you're gonna rate it, so you have to choose one.
Yeah, you have to choose between center and the edge. Okay? So like the one that hitting a cosine of 0.8, I think with cosine of x, I think you want your maximum to be at 1. Because your cosine graph, the highest value it can output is 1. So that particular question, you have to choose 1 for that situation. But this one, I'm gonna choose one here as well. So I'm gonna give you a question so for you to find out the error. So here's a question that I want to do. I want to choose f of x equal to square root of x. And I want to use second degree polynomial. Second degree Taylor polynomial. So you don't have to, how many derivative you have to take if second degree? Three, because the second one is find the polynomial. The third degree is find the error. So second degree Taylor polynomial, and at center is equal to 4. You want to find out the error. The maximum error can occur between 3 and 5. So in this case, you want to choose, which value it's going to give is between 3 to 5. Whatever value, there's only one value between 3 to 5 is going to give you maximum errors. So you have to think what that value is supposed to be. But you have to find out 2 degree polynomial, you have to find out the error, and then which is third degree, and then you have to decide is the maximum error that you can do is at 3 or at 4 or 5 or 3.9 or 3.5, but maximum, right? You had to pick the maximum value. So there's only one value makes sense between 3 to 5. Yeah, so you had to find out the second degree polynomial first, which is stop at a second derivative. That is your second degree, but you had to do one more to find the error. One extra one. I don't know if I told you your mock exam is gonna March 29. Did I tell you that? Friday, but if you cannot make it, I think Isabel cannot make it because Davidson trip. I don't know if somebody else have soccer game that day. Nathan probably have soccer game that day. So just come on Friday. I'll just throw in that room. I'm gonna have ping pong Friday on this side. You're gonna be taking the test on the other side. Huh? What date? March 29. Okay, so you take on Friday. Can you take on Friday? Yeah. And also ping pong. There's a ping pong tournament I'm gonna host at this weekend on 10 o'clock. If you guys want to show up, you'll be out of town. Where are you going? Huh? West Oak Mall. Are you good at ping pong? I never seen you play before. I see Wesley play all the time. I see Lyndon play. I never see Anderson might be secretly like Taiwan pro player. Taiwan is actually really good at ping pong too.
Are you serious?
Huh? He's not. Taiwan. I am not communist. I'm from Taiwan. We have democracy. We fight in Congress, like physically fighting. You never seen it? Have you seen Taiwan Congress? Look at Taiwan Congress. It's so funny. It's the funniest thing that you will see. Here, let me show you. No, I'm gonna finish your problem.
Wait, what do you mean? What did I do? What? Did I do something I don't even remember? Yes.
What did Corbin do? What did Corbin didn't do? That's a question. We should,
You do.
what did Corbin didn't do?
What did I do?
Corbin's a liar.
What did I? Don't trust that person. She was crazy when she wrote that.
Is she still crazy?
Yeah.
Okay. Maybe we want to find an error.
Is that 3.5 or 3 comma 5?
3 to 5. So your range is 3 to 5. You try to find out the maximum error between 3 to 5.
Is 3 considered?
3 is included. Yes. We are trying to find out how big what's the maximum remainder you can have, maximum error. You also going to give me a Taylor polynomial to the second degrees.
What number are we trying to solve? What are we approximating anything?
You want to find out the maximum error. So between 3 to 5, which value is going to give you the maximum error? Yeah, we're processing something 3 to 5, but we also need to find out between 3 to 5, what's the maximum error I can have? You might need a calculator with this.
I'm sorry that I know my factors of 2. Like, what? So we need to, okay? No, we can't make 3. So we need 3.
Between 3 to 5, you can pick anything 3 to 5. Because that's an interval. That's an interval between 3 to 5. So what can I pick, right? We want to find out, what if I want to approximate like square root 3 or square root 5? Which one's going to give me the most error? What's the highest error that you can have? Z could be anywhere between 3 to 5 inclusive. Corbin, worry about your remainder. The answer is not 3. The answer is small. It's roughly. You figure out. I'll tell you the error is right. You go ahead and evaluate the error. Whatever. I don't know. That's what way to figure out. You gotta figure out which one's the maximum error. Well, it depends on the third derivative. Is the z is on the bottom or z is on the top? Yeah, if z is on the bottom, you want a certain number. If z on the top, you want a
bigger number.
Yes. Well, you deduce that reason. It's about a reason. Well, z has to be between 3 to 5, but usually I'll pick the n because the n is going to give you the maximum minimum. So you have to choose between inclusive 3 to 5. You can choose the middle, but you can compare all 3, see which one's going to give you a maximum.
You don't know.
I know the answer. Sorry, I meant to write Bragg.
Wait, so
That's basically that's what the x is a minus square root of 5. So now the actual x value.
so we found out.
5.
Ooh.
So that's the first derivative, right? Second derivative is
Right, you plug in x minus 4. But then the actual x value is going to be what you're trying to solve. It's, but we don't know what we're solving.
We just assumed it would. So like what number is it? Wait, so it's either any number. Wait, is this centered around?
So then P2 equals 2.
Oh, no, it's not. We're not estimating. Not estimating. So if we're not estimating. I just did it.
Wait, we're not. That's
I would say the What are we estimating?
Okay, so we're not solving.
No, you find zero flavor. I don't know.
I'm doing my work.
No, you're not.
Bro, doing my own.
Wait,
oh sorry, this one
Why are
is
you guys snatching?
If we're dating,
obviously.
How far along are you?
It's like 6 months back.
I don't even see it.
You can say
so my Taylor polynomial to the second degree is gonna be f of 4 plus f prime of 4 x minus 4 to the first 1 factorial plus f double prime of 4 times x minus 4 to the second to the 2 factorial, which is 2. This one is going to give you 2 plus x minus 4 to the fourth minus x minus 4 to the second to the 64. So this is the Taylor polynomial. Is that okay? Now the third derivative, so f to the third derivative is going to be x equal to 3 over 8 x to the negative 5 over 2. Now we know that we wanted to have z, which is 3 over 8 z to the 5 over 2 on the bottom. Now the choice between 3 to 5, the best choice is actually 3. Because you want to divide it by the small value. Now sometimes z is on the top, right? Sometimes z is on the top. You want to divide it by bigger value. You want to have a bigger value if z is on the top. Z is on the bottom. You want to choose 3 because 3 is a better choice. So r of 2 of x, which is f to the 3 of z times x minus 4 to the third over 3 factorial. Because your next term, the second remainder is your third degrees of Taylor polynomial. So it'll be 3 over 8z to the 5 over 2 times 3 factorial times x minus 4.
It's the square root of 240.
Now you gotta be careful this part. There's also x as well, right? So you want to pick this one to be 3. 5 over 2. That's your maximum. Times 3 factorial. Now I hear, what do I need to choose? 5.
We choose a different x density value. You just do every value.
So I pick the n.
I mean, you have to get the thing.
So that's equal to 16. Yeah, you will get the same thing because you choose 3, it's gonna give you negative, it's just an absolute value. So it's still fine. So at this case will be 16 to the 3 to the 5 over 2. And that's roughly 0.004. So even to the second degree polynomial, this error only occurred with 0.004. And that's a maximum error. That's not even a minimum error. Minimum, if we divide it by 3, if we divide by 5, then that's going to be even small. It's going to be, yeah, it's going to be smaller.
What happened to the cube at the over there?
What happened to the what?
Cube.
Now, we're just going to look at a particular question about this. So we're going to go to the worksheet, a certain worksheet. You should finish. If you did the whole worksheet, you're going to be excellent. Like you're going to be fine with everything. So, so for this, particular one, they give you right here, right? This is the actual AP exam question. They say f of 5 is 6, f prime of 5 is equal to 8, f double prime of 5 is equal to 30, f third prime is a fifth. Now this is a third degree Taylor polynomial. You can write it out very easy. But they also say this. F of 4 of x, which is the error. So they say, hey, the maximum value you can do is 75. They give you 75 straight. So all you gotta do is type in 75 over there, and that is the maximum. So that part f of z is gonna be 75 because maximum you can get is 75. And then you're gonna figure out how to do a problem. So let's figure out this one. Question 3. You probably already did the first part. So the interval basically is plus the error and minus the error. And that's it. And this is a good question, so. But you should finish everything. But Taylor polynomial is not hard. I think people just scare. Yes?
Find the interval when you do the plus and minus. You're doing that based on what you got when you just plugged in the x originally to like this 4 terms or whatever.
The plus minus is error. So that is your the remainder.
But like what you're adding and subtracting to.
Yeah, it's based on your third degrees. So it'd be third degree at, let's say, at this particular case, it'll be 5.2. I'm gonna plug in 5.2. And then once I get an evaluation of 5.2, it's gonna be plus the error and minus error that becomes the intervals. Does that make sense? It's like you have a bottle of water and they say, well, it's a plus minus like half gram of carbohydrate. So that's the error, that because you drop the carbohydrate or sugar inside the thing, it might have some error to it. And that's the error that they are looking for. There's uncertainty, I think. That's what I call it in physics, right? I don't know. It's like, did Greenwald teach uncertainty? I don't know. This one is no calculator. I don't remember which one is this one. Because usually they're on question 5 and 6.
Is it? Are we doing this one? I mean, are we doing some?
But this one you can use calculator, I think. We can show you a couple questions without calculators today.
Well, I think they're really fun. What's that? Sure. Most likely, what? No. You're gonna be famous. I'm gonna be famous. For all of you.
According to family history, I don't know.
I'll make sure that like if I do ever do anything horrible, I'll make sure to say it's your fault.
Yeah, now before you like doing something crazy, have been more right now. It's all Mr. Gay's fault. And they'll come back and interview me. I'm
You want to know.
AB is a plus or minus. 50 is a
Okay,
good.
good. Next.
Be a short test.
Yeah, it's not gonna be long.
Don't make it too long.
She has it. Oh.
Wow.
Yeah, it's fine. I just got the bike here.
4 months, guys.
I guess it.
He haven't called.
Well, no,
Wait, you don't need to call if you bite someone.
Is that not what happened? That's like
No,
there's a lot
you
of
can
people
call
that
if
bite.
there's stitches.
No. Well,
Oh, I thought it was I swear I thought it was prevent
No.
biting.
she's been like biting for.
I'm sorry, I'm so bad with it.
We were thinking it was because of like allergies. Yeah, so it's probably because
Wait, what happened?
she has allergies, so she's been like at her paw,
Oh,
like
that was
biting it. Yeah,
Your dog is so sweet.
she says
Remember that one time I met her? You're so sweet.
she's wonderful.
I love
prevent people biting.
Well, yeah, but not biting people. It's for her like gnawing. It's to prevent her from like herself.
Biting herself.
Yeah.
So
it
I
is
was
for
sort
biting.
of right, but
It was for biting. It's not for people.
but sometimes do they do that for biting for people too?
I don't think so. I don't think it would help that much. Like if a dog is that aggressive, it would probably be able to get past
Because
it.
that's the range of her mouth, so it's cover her range of her mouth. So you prevent from people biting. Anyway, I don't know anything about dogs. I have a rabbit. The rabbit's funny. Like he's he's only close to my wife. So anybody ever get near my wife, he bites. So my younger son will be giving him a hug, give her a hug, and he'll bite his ass. It's like, no, don't get near me. They breed him. Like territorial. Food.
So is this the last new thing we've learned this year?
Now we have to learn. We have in a week. We're gonna learn. When we come back the first week, we're gonna learn polar equation, which is one more FRQ, and the parametric. Parametric is easy. That should be one day.
That's the thing where it's like T, right?
Yeah, but that's
I don't
easy
remember
because
how
this
this
is
works.
kinematic. So the equation is fairly easy. It's really self-explanatory. So you can probably do it right now. It just have x perspective and y perspective. So that's one day, and we're gonna spend 3 days talk about your polar equation. Polar equation that's a little bit harder.
Yeah, because in the first problem, because you're doing cosine, for the z, would you be doing uh, n
The maximum
f
output.
n plus one to the n plus one x to the 2n plus 2 over 2n plus 2 factorial? Is that what you would do? Because you have 2n
Are
and
you
2n?
talking about the z?
Yeah.
Well, that one you had to creatively think. Is that the one with cosine?
Yes.
Okay. Now when you had to creatively think, like the maximum output of cosine is what? Think about what's the maximum output you can do to the cosine.
1.
Yeah. So your f of z has to be what? It cannot be.
Okay, so you
That's the word.
so you have to go all the way back around to get to
That one.
which means that it would be f of 8.
your f of z is going to be 1 because that's the maximum output of the function. Because the cosine graph is oscillating between negative 1.
Eight factorial times 1. So it's just x to the 8 over 8 factorial.
Over 8 factorial.
Right?
This is 8th degree.
Well, it's not 8th degree, but in order to have the z would have to be. Wait, I think I was.
No, f of z is going to be 1. I think they only say it's 3rd degree, right? What do they say?
Yes, but well,
Well, you don't have to go to 8th degree. You just have to go
it's
to
4th degree. But if you did the 5th degree, then it would just cancel out because it's cosine, right? So you'd have to do like 6th degree. No, oh, because wait, because you have to find cosine of 1. Is that what you have to do?
wait,
Wait,
f of z is 1.
f of z is 1. So f of z equals cosine of 1. No, f
So
of
it's
z
still,
wait,
if they
f of
say,
z equals 0. Because f of z is 1 and f is cosine. So
But-
z equals 0.
you only need to go to 5th derivative.
Wait, I mean,
If they say 4th degree.
well, no, because 5th derivative, that just means everything would end up being 0, right? And that would mean that there would be no error.
Well, you plug in z. Your maximum is z.
Well, yeah, but f, that would mean that you, wait, let me, I need to look back over this, because I don't know if I understood. So it would be f to the 5 of z, right?
And f
But that would mean f to the 5 of, so f to the 5
you
of,
have to get the value because you're trying to get
Zero.
maximum.
but f to the 5 of 0 is 0.
No. F of 0.
F of 0 is
F of
1.
0 is
But then you
1.
have to do f to the n plus 1 of z. Right?
Yeah, but
But that would be 0.
no.
But z is 0.
Z is 0, but cosine of 0 is 1.
Right, but f to the 5 of x is sine of x.
No, you're gonna use to the, if they say it's 4th degree, you're gonna stop at 5th degree. Not 6th degree.
But no, but the 5th degree is negative sine of x.
So what?
Negative sine of 0 is 0.
You're gonna get f of z to the 5th degree of something, and that f of z has to be 1. Has to be 1.
So you
Cannot
have to
be
do
0.
So you have to do f to the 8.
No. Only the 5th. If 4th degree, it's just m plus 1. F to the m plus 1. But it's m plus 1 to the z. So you're not plugging the 0 into the function. Well,
So it's negative sine of z, but z equals 0. So it would be 0.
no, it's not 0. It's 1.
So z is pi over 2.
Just think about it. It doesn't matter cosine or sine function. The maximum output of anything. We're not trying to evaluate at the
So you need to make sure it's f of z does not have to equal 1. F to the 5th of z has to equal 1.
Yes.
Okay,
output.
that's where I misunderstood you.
Because your
Okay.
average z it's gonna be your maximum of your cosine wave or sine wave.
So z equals pi over 2.
You don't worry about what d is. You just need to worry about f of d.
Right. So then it's x to the 8 over 8 factorial, but and then you're solving. So it's
I don't know why you have 8 factorial. It's really
isn't it-
scary.
or, sorry, not 8 factorial. Sorry, no, that wasn't. So it's 5 factorial. 5 factorial. Sorry.
Yeah, it's
X
really,
to the 5th over 5 factorial. So it's 0.8 to the 5th over 100. And then the calculator is permitted.
so you look at. Let me show you what happened here.
Yeah. Sorry, I thought you were. I thought you had said f of z had
Yeah.
to be 1, so,
So,
that's why I got confused.
See, this f of 5 is the output of sine function. The output of sine function is gonna be 1. That's it.
Okay.
Because it's not like you had to get
Okay.
whatever.
Let
Does
me
that make sense?
0. And it says okay. It says 3 decimal places, so I can just do 0.003. So it's 0.694 and 0.7. Yes. 0.695 is between 0.694 and 0.75.
Oh, fuck no. Trump, stop with the trade war. My stock portfolio is hurting. I understand why you're doing that, but there had to be a better way to do it. Ah, Trump.
Let's see. Oh, I see. Yeah, it does work.
so many games in which flag is hard and able to go off the bounce without anybody coming over from the weak side. And Mom and Dad, who've been in so many games in which flag is hard and able to go off the bounce. What? You can hear? It's the look at his eyes. Look at his head. That's for concentrating. Yeah, that's over. Yeah. Good night. Good night. Where's Steph Curry? When you need him. Where's night night? Dropping on. What? Get to here. It's the look at his eyes. Look at his head. That's for concentrating. Oh yeah.
Wow, this is insane. Look at that.
Yeah.
Look at the word.
What's your emergency? I just like another girl's selfie. So what? Maybe it's Albania. See hands right now. Hurry. Bring a lot of men. It's what? Helicopters. Hurry up.
Are you stressed?
Tony, come on, Chris.
Take your time. Don't turn. Stay close to the rebound. Here comes Draymond. Pushing it out to Curry. Put your hands up. 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 Put your hands up.
牛啊！国际顶级科学杂志《Science》最近发了个论文，日本科学家搞了个物理外挂，说用机械手套这种外骨骼能帮人突破身体极限。谁搞的？索尼实验室的 Shinichi Furuya， 这哥们儿自己就是钢琴家，以前曾因过度练琴练到手受伤，发现人手速度有极限，于是怒造了个机械手套。他说灵感来自老师手把手教琴，干脆用机器人模拟这种被动教学，怎么运作？这外挂靠电机控制每根手指关节，1秒能弯4次，弹和弦颤音这种高难度动作跟玩似的，躺着变强，戴上30分钟，机器手带着你手指动，不用自己使劲，速度和准度直接飙升。更绝的是，没练的那只手也跟着变强。科学家说，肌电图显示大脑控制手指的模式被改写，就是大脑被改造了。他还轻电引擎，外骨骼只包手背和指根，弹琴时完全不影响姿势。有网友就 就调侃这玩意打电竞是不是能上王者？实测有多猛？实验室拉来了118名职业钢琴家当小白鼠，先让钢琴家们用右手练习一个复杂的弹奏手法，在熟练度达到瓶颈后，用外挂30分钟，结果演奏速度和准确率显著提升。苦练10年不如科技开挂，1万小时定律被撕得稀碎。那这除了在钢琴家手上还能干啥呢？它还能应用于中风或神经系统疾病患者的手部功能恢复，不仅是音乐领域的创新工具，也为机器人技术与人类能力增强的融合提供了新范式，并推动轻量化消费级外骨骼的发展。关注我，围观更多逆天黑科技。牛啊！国际顶级科学杂志《Science》最近发了个论文，日本科学家搞了个物理外挂，说用机械手套这种外骨骼能帮人突破身体极限。谁搞的？索尼实验室的 Shinichi Furuya， 这哥们自己就是钢琴家，以前曾因过度练习受伤，发现人手速度有极限，于是怒造了个机械手套。他说灵感来自老师，手把手教琴，干脆用机器人模拟这种被动教学，怎么运作？外挂靠电机控制每根手指关节，1秒能弯4次，弹和弦颤音这种高难度动作跟玩似的，躺着变强，带上30分钟，机器手带着你手指动，不用自己使劲，速度和准度直接飙升。更绝的是，没练的那只手也跟着变强。科学家说，肌电图显示大脑控制手指的模式被改写，就是大脑被改造了。它还轻电引擎，外骨骼吃饱手背和指根，弹琴时完全不影响姿势。有网友就调侃，这玩意打电竞是不是能上王者？实测有多猛？实验室拉来了118名职业钢琴家当小白鼠，先让钢琴家们用右手练习一个复杂的弹奏手法，在熟练度达到瓶颈后，用外挂30分钟，结果演奏速度和准确率显著提升。苦练10年不如科技开挂，1万小时定律被撕得稀碎。这除了在钢琴家手上还能干啥呢？它还能应用于中风或神经系统疾病患者的手部功能恢复，不仅是音乐领域的创新工具，也为机器人技术与人类能力增强的融合提供了新范式，并推动轻量化消费级外骨骼的发展。关注我，围观更多逆天黑科技。国际顶级科学杂志《Science》最近发了个论文，日本科学家搞了个物理外挂，说用机械手套这种外骨骼能帮人突破身体极限。谁搞的？索尼实验室的 Shinichi Furuya， 这哥们自己就是钢琴家，以前曾因过度练琴练到受伤，发现人手速度有极限，于是怒造了个机械手套。他说灵感来自老师，手把手教琴，干脆用机器人模拟这种被动教学，怎么运作？这外挂靠电机控制每根手指关节，1秒能弯4次，弹和弦颤音这种高难度动作跟玩似的，躺着变强，带上30分钟，机器手带着你手指动，不用自己使劲，速度和准度直接飙升。更绝的是，没练的那只手也跟着变强。科学家说，肌电图显示大脑控制手指的模式被改写，就是大脑被改造了。它还轻电引擎，外骨骼吃饱手背和指根，弹琴时完全不影响姿势。网友就调侃，这玩意打电竞是不是能上王者？实测有多猛？实验室拉来了118名职业钢琴家当小白鼠，先让钢琴家们用右手练习一个复杂的弹奏手法，在熟练度达到瓶颈后，用外挂30分钟，结果演奏速度和准确率显著提升。苦练10年不如科技开挂，1万小时定律被撕得稀碎。那这除了在钢琴家手上还能干啥呢？它还能应用于中风或神经系统疾病患者的手部功能恢复，不仅是音乐领域的创新工具，也为机器人技术与人类能力增强的融合提供了新范式，并推动轻量化消费级外骨骼的发展。关注我，围观更多逆天黑科技。牛啊！国际顶级科学杂志《Science》最近发了个论文，日本科学家搞了个物理外挂，说用机械手套这种外骨骼能帮人突破身体极限。谁搞的？索尼实验室的 Shinichi Furuya， 这哥们自己就是钢琴家，以前曾因过度练琴练到受伤，发现人手速度有极限，于是怒造了个机械手套。他说灵感来自老师，手把手教琴，干脆用机器人模拟这种被动教学，怎么运作？这外挂靠电机控制每根手指关节，1秒能弯4次，弹和弦颤音这种高难度动作跟玩似的，躺着变强，带上30分钟，机器手带着你手指动，不用自己使劲，速度和准度直接飙升。更绝的是，没练的那只手也跟着变强。科学家说，肌电图显示大脑控制手指的模式被改写，就是大脑被改造了。它还轻电引擎，控制手手背和指根，弹琴时完全不影响姿势。网友就调侃，这玩意打电竞是不是能上王者？实测有多猛？实验室拉来了118名职业钢琴家当小白鼠，先让钢琴家们用右手练习一个复杂的弹奏手法，在熟练度达到瓶颈后，用外挂30分钟，结果演奏速度和准确率显著提升。苦练10年不如科技开挂，1万小时定律被撕得稀碎。这玩意儿完美的实力大战，中风或神经系统疾病患者的手部功能恢复，不仅是音乐战术，有人等你这要下技术，这才是最科学的不是啊！比起床先跑10公里，下午级战术训练后还要下练2小时体能。社交媒体上战术训练视频，他的肱二头肌线条能让健身博主自惭形秽。不过你小看藏獒类的性格，有内部人士透露，张继科为对战这场对决，偷偷请了国乒前体能师制定特训计划，每天凌晨4点到海边附近折返跑，
吸收物质精华。
来，
网友辣评：呵呵，这是要新鲜度的。建议比赛时直接穿道袍上场，边打边念，乒乓心经。张继科的心理素质堪称平坎灭霸。伦敦奥运会对阵萨姆索穆斯时，曾在局间休息对流过2球，教练去买瓶水吧，这局我稳。而网上遇到冷面杀手属性更令人胆寒。成都混团世界杯打到10比0时主动让分，还能在对手感激眼神中面无表情拿下最后1分。但这场对决的特殊性在于，两人有着过命交情。张继科曾把一轮球拍赠给王曼玉，手把手教他破解沉稳的正手小三角发球。王曼玉则在张继科直播翻车时，默默刷了10个火箭帮他解围。有心理学家分析，当对手是你最熟悉的人，狠话放得越响，手握的越厉害。今日比赛前2人先互为10种小红包培养上。虽然张继科好演男女差距可通过训练弥补，但男选手的天然力量优势不容小觑。他的反手爆中不圈球、旋转强度等比现役女选手高出10%至2%。不过王曼玉早有准备，日常陪练对象是樊振东、林诗栋等男队子弟，甚至发明了女子防爆球，用更快过节和更刁钻节奏抵消力量差距。
科学家说，肌电图显示大脑控制手指的模式被改写，就是大脑被改造了。他还轻电引擎、外骨骼、持包手背和指根，弹琴时完全不影响姿势。有网友就调侃：这玩意打电竞是不是能上王者？实测有多猛？实验室拉来了118名职业钢琴家当小白鼠，先让钢琴家们用右手练习一个复杂的弹奏手法，在熟练度达到瓶颈后，用外挂30分钟，结果演奏速度和准确率显著提升。苦练10年不如科技开挂，10000小时定律被撕得稀碎。那这除了在钢琴家手上还能干啥呢？它还能应用于中风或神经系统疾病患者的手部功能恢复，不仅是音乐领域的创新工具，也为机器人技术与人类能力增强的融合提供了新范式，并推动轻量化消费级外骨骼的发展。关注我，围观更多逆天黑科技。牛啊！国际顶级科学杂志 Science 最近发了个论文，日本科学家搞了个物理外挂，说用机械手套这种外骨骼能帮人突破身体极限。谁搞的？索尼实验室的 Shinichi Furuya， 这哥们自己就是钢琴家，以前曾因过度练琴练到手受伤，发现人手速度有极限，于是怒造了个机械手套。他说灵感来自老师，手把手教琴，干脆用机器人模拟这种被动教学。怎么运作？外挂靠电机控制每根手指关节，1秒能弯4次。弹和弦颤音这种高难度动作跟玩似的，躺着变强，戴上30分钟，机器手带着你手指动，不用自己使劲，速度和准度直接飙升。更绝的是，没练的那只手也跟着变强。科学家说，肌电图显示大脑控制手指的模式被改写，就是大脑被改造了。他还轻电引擎、外骨骼、持包手背和指根，弹琴时完全不影响姿势。有网友就调侃：这玩意打电竞是不是能上王者？实测有多猛呢？实验室拉来了118名职业钢琴家当小白鼠，先让钢琴家们用右手练习一个复杂的弹奏手法，在熟练度达到瓶颈后，外挂30分钟，结果演奏速度和准确率显著提升。苦练10年不如科技开挂，10000小时定律被撕得稀碎。那这除了在钢琴家手上还能干啥呢？它还能应用于中风或神经系统疾病患者的手部功能恢复，不仅是音乐领域的创新工具，也为机器人技术与人类能力增强的融合提供了新范式，并推动轻量化消费级外骨骼的发展。关注我，围观更多逆天黑科技。牛啊！国际顶级科学杂志 Science 最近发了个论文，日本科学家搞了个物理外挂，说用机械手套这种外骨骼能帮人突破身体极限。索尼实验室的 Shinichi Furuya， 这哥们自己就是钢琴家，以前曾因过度练琴练到手受伤，发现人手速度有极限，于是怒造了个机械手套。他说灵感来自老师，手把手教琴，干脆用机器人模拟这种被动教学。怎么运作？外挂靠电机控制每根手指关节，1秒能弯4次。弹和弦颤音这种高难度动作跟玩似的，躺着变强，戴上30分钟，机器手带着你手指动，不用自己使劲，速度和准度直接飙升。更绝的是，没练的那只手也跟着变强。科学家说，肌电图显示大脑控制手指的模式被改写，就是大脑被改造了。他还轻电引擎、外骨骼、持包手背和指根，弹琴时完全不影响姿势。有网友就调侃：这玩意打电竞是不是能上王者？实测有多猛？实验室拉来了118名职业钢琴家当小白鼠，先让钢琴家们用右手练习复杂的弹奏手法，在熟练度达到瓶颈后，外挂30分钟，结果演奏速度和准确率显著提升。
Yeah.
It's 40 minutes.
You made it open. And if you close it, then but we also put the grade for some reason. So on the Olympia,